In this video, we're going to start the KutaSoftware Infinite Algebra 2 free worksheet solving absolute value equations. I'll leave a link in the description below so you know how to access this worksheet. Our directions are to solve each equation. And before we get started with that, let's quickly review the absolute value. We know that the absolute value of positive x is equal to x, and the absolute value of negative x is also equal to x. So knowing this, we're saying that the absolute value of 3x, if that's equal to 9, this value of 3x, what's inside the absolute value, can either be negative or positive. So that's going to be either a positive 9 or it's going to be a negative 9. Since the absolute value of x equals x and the absolute value of negative x also equals x. So with that being said, we have that 3x equals 9, and we also have that 3x equals negative 9. So we're going to solve for each. Starting with the equation where it's equal to positive 9, we're going to divide both sides by 3 to get that x is equal to 3. Now moving on to the next equation where 3x is equal to negative 9, dividing both sides by 3, we get that x is equal to negative 9 divided by 3, which is the negative 3. So x can equal either 3 or negative 3. And let's go ahead and write this as a set. So x is equal to 3 or negative 3. Let's go on to number 2. In number 2, we have the absolute value of negative 3r equals 9. So with that being said, we're saying that this negative 3r is either equal to 9 or it's equal to negative 9, because the absolute value of 9 equals 9 and the absolute value of negative 9 equals 9. So writing those two separate equations, negative 3r equals 9, or we have that negative 3r equals negative 9. Dividing by negative 3 in the first equation, we get that r is equal to negative 3. Divided by negative 3 in the second equation, we get that r is equal to positive 3. So writing that as a set, again, our variable is equal to either negative 3 or positive 3. In number 3, the absolute value of b divided by 5 equals 1. So that means that what's inside this absolute value, b divided by 5, equals either 1 or a negative 1, since the absolute value of 1 equals 1 and the absolute value of negative 1 also equals 1. So writing our two separate equations, b divided by 5 equals 1, or we have that b divided by 5 equals negative 1. In order to solve, we're just going to multiply both sides by 5. The 5s will cancel out on the left-hand side, and we'll get that b is equal to positive 5. And when we do the same to the other equation, multiplying both sides by 5, we get that b is equal to negative 5. So b can either be 5 or negative 5 for number 3. In number 4, so that means that negative 6m equals either positive 30 or negative 30. Writing my two separate equations, I'm going to start by dividing both sides by negative 6 for the equation that equals positive 30. When I do so, I'll get that m is equal to negative 5, since 30 divided by negative 6 is negative 5. When I divide by negative 6 in the equation that equals negative 30, I'll get that m is equal to negative 30 divided by negative 6, which is a positive 5. So we have that m can either equal negative 5 or m can equal 5 for number 4. In number 5, I have the absolute value of n divided by 3 equals 2. That means that n divided by 3 either equals positive 2 or it equals negative 2. So let's go ahead and write those two separate equations. Solving for when n divided by 3 equals 2, we're going to multiply both sides by 3. The 3's will cancel out, so I'll be left with n equal to 2 times 3, which is 6. When n divided by 3 equals negative 2, I'll also multiply both sides by 3. 3 times n divided by 3 is simply n, and negative 2 times 3 is negative 6. So I'll get that n is equal to 6, or negative 6 in number 5. In number 6, negative 4 plus 5x, the absolute value of that quantity, is equal to 16. So that means that negative 4 plus 5x either equals 16 or it equals negative 16. So I have negative 4 plus 5x equals a positive 16, or negative 4 plus 5x equals a negative 16. Starting with when negative 4 plus 5x equals the positive 16, I'm going to add 4 to both sides. So this is going to be like solving a multi-step equation. Negative 4 plus 4 is 0, 0 plus 5x is 5x, and that's equal to 16 plus 4, which is 20. Next, I'll divide both sides by 5 to isolate my x and get that x is equal to a positive 4. In my equation where negative 4 plus 5x equals negative 16, I'm going to start by adding 4 to both sides to get that 5x equals a negative 12. Then I'll divide both sides by 5 to get that x is equal to negative 12 fifths. A negative 12 fifths cannot be simplified, so my answer in number 6 is that x equals 4, or x equals negative 12 fifths. In number 7, I have the absolute value of negative 2r minus 1 equals 11. So negative 2r minus 1 equals a positive 11, or it equals negative 11. So I'm going to set up my two separate equations and solve. Adding 1 to both sides, I'll have that negative 2r equals a positive 12. When I divide by negative 2, I'll get that r is equal to negative 6. For when my equation equals negative 11, I can add 1 to both sides to get that negative 2r equals a negative 10. When I divide by negative 2, I'll get that r is equal to negative 10 divided by negative 2, which is a positive 5. So r equals either negative 6 or a positive 5 for number 7. In number 8, the absolute value of the quantity 1 minus 5a equals 29. Let's set up the two separate equations. I'll have that 1 minus 5a equals a positive 29, and I'll also have that 1 minus 5a could equal a negative 29. Solving for a when 29 is positive, I'll subtract 1 from both sides to get that negative 5a is equal to positive 28. Dividing by negative 5, I'll get that a equals negative 28 fifths, and that cannot be simplified. Solving for a when the quantity within the absolute value is negative, I'll subtract 1 from both sides to get that negative 5a equals negative 30. Then divide both sides by negative 5 to get that a is equal to negative 30 divided by negative 5, which is a positive 6. So that means that a equals either negative 28 fifths, or it could also equal 6. In number 9, I'm solving for when negative 2n plus 6 equals a positive 6, or when that equals negative 6. Because remember, the absolute value of 6 equals 6, and the absolute value of negative 6 also equals 6. So negative 2n plus 6 equals 6, and negative 2n plus 6 equals negative 6. Subtracting 6 from both sides, when the quantity within the absolute value is positive, I'll get that negative 2n equals 0. So I'll divide by negative 2 to get that n is equal to 0. Solving for n, when negative 2n plus 6 equals negative 6, I'll subtract 6 from both sides to get that negative 2n equals negative 12. Dividing by negative 2, I'll get that n is equal to a positive 6. So n is equal to 0 or 6 for number 9. Now let's go ahead and plug each value of n into the equation and see if it indeed does equal 6. If we were to plug 0 in for n, 2 times 0 is 0, so we'll be left with the absolute value of 6, and that indeed equals 6. When we plug 6 in for n, we're going to have negative 2 times 6, which is negative 12, and remember this is within the absolute value, so negative 12, we're adding 6 to that, we have to see if that equals 6. Negative 12 plus 6 is going to give us a negative 6, so we have the absolute value of negative 6, and that indeed equals 6. So you can see that whether we plug 0 or 6 in for n, we get that the absolute value of negative 2n plus 6 equals 6. And I'll go ahead and stop the video here. Continue on to the next video, where I'll do a few more problems in this worksheet. However, before you do that, please remember to like this video and subscribe to my channel. All likes and subscriptions are greatly appreciated. Also, if you have any comments, feel free to leave them below.